Okay, we have a situation now where we have an initial angular velocity of 700 degrees per second, something rotating at 700 degrees per second, another and rotating at some later time at 300 degrees per second. So what can we reason out? Well, it's exactly the same situation we have here. It's just that the numbers are different, and now we have degrees per second. And we could express 700 degrees as almost 2 revolutions. Be what? 1 and 1/18 of a 1 and 17/18 of a revolution. But we don't want to do that. We'll just work with degrees. So the average angular velocity, if we start at 700 and at 300, the average is going to be 500. Very clearly, average is going to be 500 degrees per second, and the change from 700 to 300 is negative 400, so it's negative 400 degrees per second. We want to know the average rate of change of omega with respect to t. That's what we call alpha. Okay, and I think it's stated that the angular velocity changes at a constant rate, so that the change is uniform. So that alpha is actually uniform, so we could drop the bar over that and just call it alpha. In any case, the average rate of change of omega with respect to t is what? By definition of rate of change, that's change in omega divided by change in t, which is going to be negative 400 degrees per second divided by the same 12 seconds. And that comes out negative 33 1/3 degrees per second squared. The change in angular position, the delta omega, is analogous to a delta S, analogous to a displacement. It's the average omega times delta t, and the average of omega is 500 degrees per second. So 500 degrees per second times 12 seconds is 6,000 degrees. Okay? So that's fairly straightforward. Now, just as we can reason out angular motion in a way that's completely analogous to the way we reason out linear motion, we could write down the equations of uniformly accelerated angular motion. Okay, I'm not going to do that. I'll just mention that we could reason out the equations. The two most basic equations, omega average is omega naught plus omega f divided by 2. You multiply that by delta t, and you get your delta theta. So instead of saying delta s is v naught plus vf over 2 times delta t, you say delta theta is quantity omega naught plus omega f over 2 times delta t, and so forth. So we can carry this analogy quite far. When we get to work and energy, then we have to be a little more careful about how we use our quantities, but we'll get to that a little bit later.